Garbage collection is a memory management technique is used by programming language like C Sharp and Java, in which these languages reclaim memory which is occupied by objects which are no longer used by program or not reachable inside the scope. So so main purpose of garbage collection is release memory and prevent memory leaks, and also uh, making efficient use of available memory. So we have some steps to use used in memory collection. Number one, tracking all references. So in this we track down all references which are allocated in our program, and in that this garbage collection, we make the list of the references. And second is check the reference is alive or not, and we check all the references in our scope. And after that, next step is marking, so we mark them as a is alive or not. And then we use sweeping again, so which is marked as alive, so we remain that as a there, and other which is not marked as alive, we just removed that those memory from the we deallocated that those memory and release them and make them use for further process. So these are the steps used in our memory garbage collection. And yes, for example, we created an object inside a program, and like we created a player object there in C sharp. So we don't have to write any delete keyword or something extra code to free up that memory. It will be automatically collect by our garbage collector inside the C sharp program. So next is the stack memory. So in our programming memory layout, so we have a stack memory in which is used for our function call or local variables. So when we use our any function call or local variables, so it will stored as a last in first out order, so that which is our latest function call, so it will finish first, return value, and after that it will go to the called location. So main use case, we when we use recursion, so in that case that stack will form when we the last execution will be on top, and then it will pop up and return the value the call function, and then it go down and we got execute our main function which called it. So this is the order when we use stack and recursion there. And next is the heap memory. So basically it is memory to use for our dynamic allocation memory. When we create any dynamic allocation in our program, so then we use this heap memory. So basically we create a object, and in that case we use inside that a memory. And when we have this memory, so the life of these allocated memory inside the heap is longer than stack variables, and it is not bounded inside that particular function which called this memory allocated on heap. It is also goes outside of that function. So so we can use according to that, and we have to delete that so that we don't have any memory leaks.